A climate imperative, the rise of net zero buildings is upon us. The planet faces a critical challenge, climate change, which threatens our very existence. Buildings are a major contributor to this global issue, accounting for a significant portion of energy use and emissions. They consume significant energy and generate substantial emissions, exacerbating the problem. Net zero buildings offer a beacon of hope, a solution to mitigate these impacts. These structures aim to balance energy consumption with renewable energy generation, creating a sustainable future. They strive for minimal environmental impact, reducing the carbon footprint significantly. Net zero buildings represent a paradigm shift in design and construction, emphasizing sustainability. They prioritize resource efficiency and sustainability, ensuring long-term benefits. This approach minimizes the carbon footprint of the built environment, making cities greener. It aligns with global efforts to combat climate change, fostering international cooperation. The transition to net zero buildings is not just an environmental necessity, it's an opportunity to create healthier, more resilient, and economically viable spaces for the future, benefiting everyone. Deconstructing net zero efficiency, renewables, and sustainable materials. Achieving net zero status in a building is a multifaceted endeavor. It involves a holistic approach that encompasses several key aspects. Energy efficiency sits at the core of the net zero philosophy. This means minimizing energy demand through clever design and construction techniques. Renewable energy integration is another crucial component. This involves incorporating systems like solar panels, wind turbines, or geothermal heat pumps. The goal is to generate as much energy on site as the building consumes. Sustainable material selection plays a vital role in minimizing the environmental impact of construction. Choosing materials with low embodied carbon and recycled content is essential. Laying the foundation. Core principles of net zero design. Net zero building design is guided by a set of fundamental principles. The first and foremost is minimizing energy demand. This means creating highly efficient building envelopes with superior insulation and air sealing. It also involves optimizing building orientation and utilizing natural shading to reduce cooling loads. The second principle focuses on maximizing the efficiency of building systems. This includes using high-efficiency heating, ventilation, and air conditioning systems. It also means incorporating energy-saving appliances and lighting. Water management is the third pillar of net zero design. Implementing low-flow fixtures, rainwater harvesting systems, and grey water reuse strategies are key aspects of this principle. A symphony of strategies, passive design, and beyond. Achieving net zero energy balance requires a combination of passive and active strategies. Passive design strategies focus on harnessing natural elements to minimize energy consumption. This includes maximizing solar gain in the winter through passive solar design. Daylighting is another essential passive design strategy. It involves strategically placing windows and using light shelves to reduce the need for artificial lighting. Natural ventilation is a passive cooling strategy that utilizes operable windows and strategically placed vents. Advanced insulation techniques, including high-performance windows and insulated concrete forms, play a crucial role in minimizing heat transfer and reducing energy demands. Intelligent buildings are at the forefront of the net zero movement, thanks to the revolutionary impact of smart technology and the Internet of Things, or IoT. These interconnected devices communicate seamlessly to optimize energy use. These advancements are transforming how we manage energy in net zero buildings, making them more efficient and sustainable. Building automation systems equipped with intelligent sensors can monitor and control various building systems in real time. This means they can adjust lighting levels, HVAC operation, and other energy-consuming processes based on occupancy and environmental conditions, ensuring optimal energy use. Smart grids and energy storage solutions are also integral components of net zero buildings, providing a reliable energy supply. These technologies allow buildings to store excess energy generated from renewable sources such as solar and wind power. They can then use this stored energy during periods of high demand or when renewable energy generation is low, maintaining efficiency. By doing so, buildings reduce their reliance on the grid and enhance their energy independence, contributing to a more sustainable future. navigating the hurdles, challenges in net zero building implementation. Despite the numerous benefits, several challenges need to be addressed to accelerate the widespread adoption of net zero buildings. One significant hurdle is the higher initial investment cost. Net zero buildings often require advanced technologies and materials, which can increase upfront expenses. Grid interdependence poses another challenge, as the intermittent nature of renewable energy sources requires reliable grid connections for balancing energy supply and demand. Performance verification is crucial to ensure that net zero buildings operate as intended. Establishing standardized measurement and verification protocols is essential for ensuring accountability and transparency. Materials of the future: innovation and advancements. The future of net zero buildings is intertwined with advancements in building materials. Researchers and manufacturers are constantly developing new materials with improved insulation properties, lower embodied carbon, and enhanced sustainability. Bio-based materials derived from renewable resources like timber, bamboo, and hemp are gaining popularity. These materials offer excellent insulation properties and sequester carbon, contributing to a negative carbon footprint. Self-healing concrete and smart glass are other examples of innovative materials that can enhance the performance and longevity of net zero buildings. Towards a greener tomorrow, integrating net zero buildings into a sustainable ecosystem. Net zero buildings are not standalone entities, they are integral parts of a larger sustainable ecosystem. Integrating net zero buildings into smart cities and communities is crucial for maximizing their positive impact. This involves coordinating energy management strategies, implementing smart grids, and promoting electric vehicle charging infrastructure. Furthermore, net zero buildings can contribute to a circular economy by prioritizing deconstruction and material reuse at the end of their life cycle. This reduces waste and minimizes the environmental impact of the built environment. Policy incentives and building codes play a crucial role in driving the adoption of net zero building practices. A call to action, embracing net zero for a resilient future. This is not just a trend, but a crucial step towards sustainability. The transition to a net zero built environment is not just an option, it is a necessity. Our cities and communities depend on it. As we confront the urgent challenge of climate change, embracing net zero building design and construction is paramount. Every action we take today shapes our tomorrow. Architects, engineers, policymakers, and investors must collaborate to overcome existing barriers and accelerate the adoption of net zero buildings. This collaboration is key to our success. By investing in research, fostering innovation, and implementing supportive policies, we can unlock the full potential of net zero buildings. These efforts will drive significant change. Together, we can create a built environment that is not only environmentally responsible, but also healthier, more resilient, and economically viable for generations to come. Our future depends on it. The time for action is now. Let us build a future where net zero is the new normal. Let's commit to a sustainable and resilient world for all.